Hi, in the previous lecture we learned about heights and distances and we also solved some questions. In this lecture we are going to solve some more questions. So let's get to the next question, question 9. This is the figure for it. Now before we get into solving this question, let me tell you something very important. Listen very carefully. Now in any question in heights and distances, if you have something like this is the ground level, this is the tower or a building, okay, and the angle of elevation at 2 points of the top of the building are, let's say, alpha and beta. In such questions, let's do the naming of the vertices. In such questions, you see that AB is the common side of two right angle triangles, triangle ABD and triangle ABC. So when we solve such questions, what we do is you calculate the value of AB from triangle ABD using sine, tan or cos, and again you calculate the value of AB using triangle ABC, again with the help of sine, cos and tan, and then equate these two values, right? That's the first method. Another method is you calculate this distance CD as BD minus BC. Now why did I do this? A CD, you notice, is not a side of any right angle triangle, right? So what we do is we calculate it as the difference of two sides which are parts of one or the other right angle triangle. So BD is a part of right angle triangle ABD, BC is a part of right angle triangle ABC. Now these two values we calculate and subtract to get the value of CD. So if the value of CD is given, we just substitute and we find the value of the unknown. So these are the two methods that we use. Now this triangle can be flipped by 90 degrees to get this. So here also AO is the common side to two right angle triangles. One of them is triangle AOQ and the other is triangle PAO. Fine. Now let's get to solving this question, then things will get clearer. Now see, an aeroplane when 3000 meters high passes vertically above another aeroplane at an instant when the angles of elevation of the two aeroplanes from the same point on the ground are 60 degrees and 45 degrees respectively. Let me draw this figure for you. Let's say this is the ground level, here is the observer, and one of the aeroplanes is at a height of 3000 meters. This is given, right? Now this aeroplane is given, it passes directly above, right, another aeroplane. Let's say that aeroplane is at Q. Now the angle of elevation of P is given to be 60 degrees and the angle of elevation of Q is given to be 45 degrees. This is A, this is 90 degrees, and we have to find the vertical distance between the aeroplanes. That means we need to find the distance PQ. Fine. So this is how I got to this figure. So you've got one aeroplane at P, the other aeroplane at Q, and then the angle of elevation of the first aeroplane is 60 degrees, of the second aeroplane is 45 degrees, right? And we need to find the distance PQ. Okay, so now as I told you, AO is the common side of two right angle triangles. One of them is triangle PAO and the other right angle triangle is triangle QAO. So what we will do is we'll find the value of AO from both these triangles and then equate them, right? Before doing that, let's assume that this height is h. Fine. Now in triangle PAO, now in triangle PAO, this angle is 60 degrees, right? And AO is the common side, right? Which is, with respect to the 60-degree angle, AO is the base and PA is the perpendicular, right? And which trigonometric ratio connects the perpendicular and the base? It's tan theta. So tan 60 degrees will be equal to perpendicular, which will be PA by base AO, or tan 60 is how much? Root 3, equal to PA is given to be 3000 meters divided by AO. So what will AO be? Take it to the other side, bring root 3 to the other side. So AO will be 3000 divided by root 3 meters. Now let's calculate, let's call this 1. Let's call this 1, right? Now let's calculate AO from triangle QAO, that is the other right angle triangle in the question. Again, for triangle QAO, the angle given is 45 degrees. With respect to this angle, AO is the base and AQ is the perpendicular. So again we are going to use tan theta. So tan 45 degrees is equal to QA divided by AO. What is tan 45? Tan 45 is 1, equal to QA. Okay, QA is, we have assumed it to be H. We're going to write H by AO. So what will be AO? Take it to the other side. AO will be equal to H. Now this is 2. Now from 1 and 2, now we got the two values of AO from two right angle triangles, right? Now we are going to equate those two values. So AO is equal to this value and AO is equal to this value. So both the values should be equal, right? So H equal to 3000 by root 3. Now let's rationalize it. So root 3 by root 3. So this will give me 3000 into root 3. Root 3 into root 3 is 3. So it will be 3000 times so many meters. So this will be 1000 into 1.732 meters, which will be 1732 meters. So what we need, the distance PQ, right? So PQ is what? PQ is PA minus H, which will be 3000 minus 1732, which will be equal to 8936 1268 meters. So this will be the answer. Understood? You can just verify the answer, so hopefully it will be correct. So let's get to the next question. Question 10. The angle of elevation of the top of a building from the foot of a tower is 30 degrees. So let's make the tower. Okay, this is the ground, and let's say this is the building. So this will be 90 degrees, this will be 90 degrees. The angle of elevation of the top of the building, so this is the tower and this is the building. Angle of elevation of the top of the building from the foot of the tower is 30 degrees, and the angle of elevation of the top of the tower from the foot of the building is 60 degrees. The tower's height is given to be 50 meters. Let's say this is PQABA, right? And this is X meters. Let's say find the height of the building, so we need to find X. Now you might question me saying that how did I assume the tower to be taller than the building? Now see, this angle of elevation is 30 degrees and this is 60 degrees. So this 60 degrees is greater than 30 degrees. Had the tower been shorter than the building, then this angle would have to be less than 30 degrees. If it's more than 30 degrees, that means that the tower is taller than the building. Fine. So this is how I got to this figure. So this is our tower and this is our building. Fine. Okay, now we need to find the height of the building, right? Now again, do you see that QB is the common side to two right angle triangles? One of them is triangle PQB and the other is triangle ABQ. So again, what we will do is we'll find the value of QB from both the triangles and then equate those two values to get the value of X. Let's see. So in triangle PQB, now we know this value PQ, right? This is the angle of the triangle, right? That is given 60 degrees, and another side of the triangle is BQ. BQ is the base with respect to this 60 degrees angle. This is the perpendicular. So obviously we are going to use tan theta. So tan of 60 degrees equal to the perpendicular, which is PQ, divided by QB. Or tan 60 is how much? It's root 3 equal to PQ is how much? It's given to be 50 meters by QB. Or take QB to the other side and root 3 to the right hand side, you get QB as 50 by root 3 meters. Let's call it 1. Now in the next triangle, in triangle ABQ, in this triangle we are going to find QB again. So here the angle given is 30 degrees. We have X here. X is the perpendicular with respect to this angle, right? And QB is the base. So again we are going to use tan theta. Theta here is 30 degrees, so tan 30 degrees equal to X divided by QB. Or 1 by root 3 equal to X by QB, or take QB to the other side, root 3 to the RHS, we get QB as root 3 times X. Now this is also QB, this is also QB. So from 1 and 2 we can say that 50 by root 3 will be equal to root 3x, or bring this root 3 down here, so 50 by root 3 into root 3 equal to x, or x equal to 50 by 3 meters, which will be 16.67 meters. So this will be our answer. Fine, understood? Okay, let's go to the next question. Question 11. This is the figure for it. Okay, a statue 1.6 meters tall stands on the top of a pedestal. So let's say this is the pedestal. Okay, this is the ground. This is 90 degrees. This is the pedestal, and there's a statue above it which is 1.6 meters high. Angle of elevation of the statue is 60 degrees from from point on the ground. The angle of elevation of the top of the statue is 60 degrees. So from here, join these two to get the line of sight. This is the observer here, this is the statue, and BC is the pedestal. So this angle is given to be 60 degrees, and from the same point the angle of elevation of the top of the pedestal. So this is the top of the pedestal. The angle of elevation of this point is 45 degrees. We need to find the height of the pedestal, which is BC, right? Now again, in this question, do you see that this is the common side of two right angle triangles? So OC is the common side of two right angle triangles, AOC and BOC. So we are going to find the values of OC from both these triangles, and then we are going to equate them. Fine. So let's solve it. So I said OC is the common side, and we need to get the values of OC from triangle AOC and triangle BOC, right? We are going to assume BC to be h meters. That is what we need to find in this question. So in triangle AOC, now in triangle AOC, this thing X is the base and AC is the perpendicular. So again we are going to use tan theta, of course with respect to this angle 60 degrees, that goes without saying. So we are going to use tan 60 degrees equal to AC by OC, or tan 60 is root 3, AC will be H plus 1.6 and OC is, we are assuming it to be X. So right now AC is what? This 1.6 meters plus H meters. So or X equal to H plus 1.6 divided by root 3. So let's call it 1. Now in the next triangle, in triangle BOC, the angle is 45 degrees with respect to this angle. Again, this is the base and this is the perpendicular. So again we are going to use tan theta. Theta here is 45 degrees. So tan 45 degrees equal to BC by OC, or tan 45 is 1, BC we have assumed to be H, and OC we have assumed to be X. So X equal to H here. Now from 1 and 2, let's use a different color. From 1 and 2, this is also X and this is also X. Let's equate the values. H plus 1.6 by root 3 equal to H. Take this root 3 to the other side. So this will give H plus 1.6 equal to root 3H. Now take this H to the other side. That will give you root 3H minus H equal to 1.6, or take H common, root 3 minus 1 equal to 1.6. So H will be equal to 1.6 divided by root 3 minus 1. Rationalize root 3 plus 1 by root 3 plus 1. So this will give me 1.6 into 1.732 plus 1 divided by root 3 minus 1 into root 3 plus 1 would be root 3 ka square, that will be 3 minus 1 ka square, which will be 1. So this will give me 1.6 into 2.732 divided by 2 meters, right? Now let me do it here in different in color. So it'll be, let's cancel it from the 0.8 times. So this will be equal to 8 to the 16, carry on, 8 3 24, 5 2 8 5 21, okay, 3 and 4, so 2.1856 meters. That'll be the answer. Understood? Let's get to the next question. Only question 12. Okay. The TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite to the tower, the angle of elevation of the top of the tower is 60 degrees. So let's say these are the edges of the canal. The canal is in between, right? TV tower is here, right? This is the tower, right? And this thing is the canal. Fine. So from a point on the other bank here, let's call it C, let's call the tower as AB. So the angle of elevation of the top of the tower is 60 degrees. So this angle would be 60 degrees. From a point 20 meters away from this point on the same bank. So basically it will go in this direction. This is 20 meters. The angle of elevation of the top of the tower is 30 degrees. Find the height of the tower. So you need to find this thing, and the width of the canal. Let's say it's x, so you need to find x, right? So this is the figure. This is how I got to this figure, right? Now let's get down to solving this. Now here again you have a common side AB, right? You have a common side AB, right, to two triangles. One triangle is to two right angle triangles, to be precise. One is triangle ABD and the other triangle is triangle ABC. So let's assume the width of the canal is x and the height of the tower is h. So in triangle ABD, now see, this is 60 degrees ABD, okay, ABD. So this is the angle 30 degrees, and with respect to 30 degrees, this side AB is the perpendicular and BD is the base, right? So we are going to use tan theta. So tan of 30 degrees equal to perpendicular by base. Tan 30 is 1 by root 3. That will be equal to AB, we have assumed to be h, by BD will be x plus 20, right? This is 20, this is x, BC is x and CD is 20. So BD will be BC plus CD, so will be x plus 20. Okay, let me just remove it. Okay, so from here we are going to calculate the value of h. So bring x plus 20 to the other side, goes in the numerator, by root 3 equal to h. So call it 1. Next, in triangle ABC, the angle is 60 degrees. With respect to this angle, this is the perpendicular, x is the base. Again we are going to use tan theta, so tan 60 degrees equal to perpendicular, which is h, by base, which would be x. Tan 60 is root 3 equal to h by x, or h will be given by root 3x. This is 2. Now from 1 and 2, What can we say? This is also h and this is also h. Both these values will be equal. So x plus 20 by root 3 will be equal to root 3 times x. Take this root 3 to the other side. We'll get x plus 20 equal to root 3x into root 3, or x plus 20 equal to root 3 into root 3 is 3x. Then take this x to the other side, so 20 will be 3x minus x is 2x, or 2x equal to 20, or x equal to 20 by 2 equal to 10 meters. So we got the width of the canal as 10 meters. Right, now we need to find the height of the tower. In this question we also need to find the height of the tower, which is h, right? So this is what we need to find. And what is h? Let's do it here. Let's choose a different ink. Okay, now from to h equal to root 3 times x equal to root 3 times 10 meters equal to 10 root 3 meters, which will be 10 into 1.732 meters equal to 17.32 meters. So this will be the height of the tower. Fine. Question 13. Okay, from the top of a 7-meter high building, the angle of elevation of the top of a cable tower. Now, whenever there is a building and a tower, assume that the tower is taller, I mean, by default, right? But then see that it's consistent with the data given, right? Most of the times, 9 out of 10 times, the tower will be taller than the building, or a flagstaff or anything else. Okay, so the building is 7 meters high, so let's make the building, this is the ground, okay, and the tower is taller. So from the top of a 7 meters high building, this is a 7 meter high building, A, B, and PQ is the tower. So from the top of a building, the angle of elevation of the top of a cable tower is 60 degrees. So make the horizontal line 90 degrees. This is 60 degrees. The angle of depression of its foot is 45 degrees. So from the same point, this is the foot of the tower, Q, right? Q is the foot of the tower. So make the line of sight. So angle of depression would be this angle, which is 45 degrees, right? Which means that this will be 45 degrees too, because these two lines are parallel, AR and BQ are parallel. So this will also be 45 degrees, because this angle and this angle will be alternate angles with AQ as the transversal. Now we need to find the height of the tower. This total height we need to find. Now you see that this is a rectangle. ARQB is a rectangle, right? Because all these angles are 90 degrees. So if this is 7 meters, AB is 7 meters, so RQ would also be 7 meters, right? This is how I got to this figure. So see that this is 7 meters, this is also 7 meters, right? If we find PR, let's say it's X, right? Or let's call it H. If we find H, then H plus 7 will be the height of the tower, right? So let's assume PR to be H. This height is H. Okay. Now see, in this question also, do you observe that this side AR is the common side of two right angle triangles? One of them is triangle PRA and the other is triangle QRA, right? This triangle and this triangle, both are right angle triangles, and AR is the common side. So let's assume it to be X, and what we will do is we are going to find the value of X from both these triangles, and then we'll equate those two values to get the value of H. Let's see. So in triangle PRA, now in triangle PRA, the angle given is 60 degrees. This X is the base, this H, this is the perpendicular. So obviously we are going to use tan theta. So tan 60 degrees will be equal to H by X. Tan 60 is root 3 equal to H by X. This implies take X to the other side. So basically we are going to find X, right? So take X to the other side and root 3 to the right hand side. So we'll get X equal to H by root 3. Let's call it 1. In the other triangle, in triangle QRA, the angle is 45 degrees. This side, with respect to 45 degrees, this is the base, AR is the base, and QR is the perpendicular. So again we are going to use tan theta. So tan 45 degrees will be equal to perpendicular, which is QR, divided by base, which is AR, or tan 45 is 1, QR is 7 meters, and AR is X. This implies X equal to 7 meters. We got the value of X. Now let's call this 2. So from 1 and 2 we can equate the values of X. So this value H by root 3 will be equal to this value 7 meters, or H equal to 7 root 3 meters, right? So now we had to find PQ, right? So PQ, therefore PQ, the height of the tower, will be H plus 7, right? Because this is what? This is PR and this is RQ. Now H is what? 7 root 3 and plus 7, or take 7 common, root 3 plus 1 meters. So 7 root 3 is 1.732 plus 1 equal to 7 into 2.732 meters. That will be equal to 7 to 14, 21, 21, 22, 2, 49, 51, 5, 19, 3 places. 19.124 meters will be the answer. Fine. Let's quickly get to the next question. 14. Okay. This is a good question. Pay attention. A straight highway leads to the foot of a tower. A man standing at the top of the tower. So okay, let's make the highway. This is the highway, this is the tower. This is the foot of the tower where the highway leads. Top of the tower, base of the tower, this is 90 degrees. Okay. A man standing on the top of the tower observes a car at an angle of depression of 30 degrees. So the car is here. Make the line of sight, make the horizontal line. So this is 30 degrees. So this will be 30 degrees, right? Let's say the car's initial position is at C. Now this car is approaching the foot of the tower with a uniform speed. So let the uniform speed, we are going to assume the uniform speed to be P, right? 6 seconds later, the angle of depression of the car is found to be 60 degrees. So let's say 6 seconds later, the car is somewhere here, and make the line of sight. This is the new angle of depression that is given to be 60 degrees. Now you need to find the time taken by the car to reach the foot of the tower from this point. So from this point to the foot of the tower, the time taken by the car is what we need to find. Fine. So this is how I got to this figure, right? The tower's height is assumed to be h. Okay. Now coming to this. Now again, if you notice that there is a common side here, right? There is a common side which is AB to two right angle triangles. One is triangle ACB, the other is triangle ABD, right? But then we need to find x, right? So what we are going to do is we are going to equate the two values obtained from the two triangles, two values of AB or H, right? So let's do it in triangle ACB. Now in triangle ACB, okay, one more thing, we assume the speed of the car to be P, which is uniform. Now from C to D, the time taken was 6 seconds. This was the time taken, right? And if P was the speed, what would be the distance CD? It will be speed into time. That will be P into 6 or 6P. So that's how I've written 6P here. Okay. Now in triangle ACB, now this, let me choose a different ink color. H is the perpendicular with respect to this angle 30 degrees and BC is the base. So obviously we are going to use tan theta. So tan 30 degrees will be equal to H divided by 6P plus X. That's clear? Or 1 by root 3 equal to H by 6P plus X, or take 6P plus X to the other side, 6P plus X by root 3 will be equal to H. So let's call it 1. Now in the other triangle, in triangle ABD now, okay, we'll again find H. So with respect to this angle of triangle ABD, H is the perpendicular, X is the base. So tan 60, we are going to use tan again. So tan 60 degrees equal to H is the perpendicular by base X, or bring X to the other side. Tan 60 is root 3, so I can write it as root 3 X equal to H. This is our second equation. Now from 1 and 2, can we equate them? From 1 and 2, 6P plus X by root 3 equal to root 3x, or 6P plus X, take this root 3 to the other side, equal to root 3 times root 3x, or 6P plus X equal to root 3 into root 3 is 3x. Now this x, take it to the other side, so 6P will be equal to 3x minus x, or 3x minus x is 2x, and that will be equal to 6P. I just shifted the LHS to the RHS and RHS to the LHS, so this is what we'll get. I just wrote it the other way around. So x would be equal to 6P by 2, that will be equal to 3P. Now this distance x, you got it as 3P, right? Now we need the time required, time taken in fact, for the car to reach from D to B. So required time will be what? Equal to distance, whatever distance it is, divided by speed. That will be equal to, what is the distance? The distance is x, which is equal to 3p. And what is the speed? Speed is p. That is what we had assumed. So pp cancels. What you get is 3 seconds. That's our answer. Fine. So if nothing is given, you know the question is asking for the time taken. So only the angles are given, no lengths are given. So know that you make some assumptions, and those assumptions, the variables that you assume, they'll get cancelled on their own. As long as you do the question correctly, you do everything conceptually correctly. Fine. So let's move on to the next question, question 15. Okay. Now, a vertical tower subtends a right angle on the top of a 10 meters high flagstaff. So, vertical tower subtends a right angle. So, tower is always taller. This is the ground. This is the flagstaff, which is 10 meters high. Vertical tower is the vertical tower AB, right? And this CD is the flagstaff. Now this vertical tower AB subtends a right angle at the top of the flagstaff here. So whenever any object subtends a certain angle at a point, you join the ends of that object, which in our case is the vertical tower. Join the ends of the object to the point where the angle is subtended, right? So this is the angle subtended by this object AB, right? This is the angle subtended, which is given to be 90 degrees, right? So here if you see, so AB is the tower, and this angle will be 90 degrees. So this is the angle subtended at the top of the flagstaff. Fine. If the distance between them is 20 meters, so this is the distance between the tower. So I wrote this is the tower, right? And this is the flagstaff. The distance between them is 20 meters. Find the height of the tower. So we need to find AB. Fine. Now let's say angle CBD is theta. Fine. Drop a perpendicular from C on AB, right? So you get PB as 10 meters. Now coming back to this theta, so this angle is theta, right? If this is theta, this angle will also be theta. Why? Because there will be alternate angles. CP is parallel to DB, right? So there will be alternate angles. Now since angle ACB, what is angle ACB? Angle ACB is what? 90 degrees. That's the angle subtended by the tower at the top of the flagstaff. That's given to be 90 degrees, right? And angle BC is what? Theta, right? So therefore angle ACP would be what? It will be 90 minus theta, because angle ACP plus angle BC is 90 degrees, right? So this angle is 90 minus theta. Fine. Now take triangle APC. Now triangle APC is a right angle triangle with a 90 degree here. Now this angle is 90 minus theta, right? This is 90 degrees. So this has to be theta, because the sum of angles in a triangle is 180 degrees, right? So this angle is theta, right? Now let's get to solving of the question. So in triangle CBD, tan theta will be equal to, why am I using tan theta? Because this side and this side are known, and this is the perpendicular with respect to theta, and this is the base. So tan theta will be equal to 10 by 20, that will be equal to half, right? Now what did we need to find? We had to find AB, right? We had to find AB. Now PB is already known to be 10 meters. If we find AP, then our problem is solved, right? So that is why I am doing all this stuff, because now I want to get into triangle APC. Now what will I do in this triangle? I'll use whatever tan theta or cos theta, sin theta, whatever I can to find the length AP. Fine. In triangle APC, what will CP be? CP will be 20 meters. Why? Because CP is equal to BD. They are opposite sides of the rectangle BDCP. BDCP is a rectangle, right? So BD will be equal to CP. Since BD is 20 meters is given, therefore CP will also be 20 meters. Now this angle is theta, right? We know CP and we want to find AP. Now CP is the perpendicular with respect to this theta and AP is the base. Fine. So we are going to use tan theta. Tan theta will be equal to CP by AP, right? Or what is tan theta? Tan theta we have already calculated, is the same theta. If theta is same, tan of theta will also be the same. So tan theta is half, CP is given to be 20, we need to find AP. So cross multiply, this will give you AP equal to 20 into 2 equal to 40 meters, right? Now what did we need to find? We wanted to find AB. AB is the height of the tower, right? AB is AP plus PB. That will be AP is 40 meters, PB is 10 meters. That gives us 50 meters as the answer. Okay. Get to the next question. A boy standing on a horizontal plane finds a bird flying at a distance of 100 meters from him at an elevation of 30 degrees. So let's say the boy is somewhere here. This is the ground. This is the bird at A. Distance, or this is the position of the boy here. Fine. Now the angle of elevation is 30 degrees. Now the distance of the bird from the boy is 100 meters. This is not the horizontal distance. Don't think it is this distance. It is not. It is this distance. This is 100 meters. Here is the boy and here is the bird, right? So it is this distance. This will be 90 degrees. A girl standing on the roof of 20 meters high building finds the angle of elevation of the same bird to be 45 degrees. Now both the boy and the girl are on opposite sides of the bird. So the girl will be somewhere here, right? At the top of a building, right, which is like 20 meters high. Here is the girl and the angle of elevation from here. So make the line of sight and the horizontal line. This angle is 45 degrees. Find the distance of the bird from the girl. So we need to find AE. This distance is what we need to find. So this is how I got to this figure. We are going to work with that figure. Okay. So we need to find this distance. This distance is what we need to find. Now see, this height is given to be 20 meters. So this will also be 20 meters. Why? Because BFED will be a rectangle, right? So this side will also be 20 meters. Now we need this side. If we find either DE or AD, right, either DE or AD, then our purpose will be served, because we know the angle, the hypotenuse is what we need to find. If we find AD or DE, we can use either sine or cos, and find the value of AE, right? Now see, with DE the problem is it is not a part of any other triangle where some values are given using which we can calculate D. So calculating D is going to be very difficult, right? So what we are going to do is we are going to calculate AD because it is a part of triangle ABC, which is a right angle triangle, and we can probably find AD and then we can substitute the value of AD and get the value of AE, right? So we are going to focus on calculating AD. Now we know this is 100 meters, this is the, with respect to this 30 degrees, this is the hypotenuse. Can we find AB? Of course we can. So in triangle ABC, now which trigonometric ratio connects or relays the hypotenuse and the perpendicular? That's sine, right? So we are going to take sine of the angle. Sine 30 degrees equal to perpendicular is AB. With respect to 30 degrees, AB is the perpendicular and AC is the hypotenuse. Sine 30 is half, AB is what we want to find first of all, and AC is given to be 100 meters. So okay, 100 into half equal to AB, or AB equal to 50 meters. Now we have found AB, right? Now can we find AD? AD will be AB minus DB. What is AB? We calculated it to be 50 meters. What is DB? It is 20 meters. So that means AD is 30 meters, right? Now we got AD. Now in this triangle ADE we are going to work, right? So in triangle ADE, now AD is what? With respect to this 45 degrees, AD is the perpendicular, AE is the hypotenuse. We are again going to use sine theta. Sine of 45 degrees will be perpendicular is AD by hypotenuse is AE, or sine 45 is 1 by root 2, AD is 30 meters, we just calculated here, and divided by AE, or AE equal to 30, just cross multiply 30 into root 2 meters, or 30 into 1.414 meters equal to 3 4s are 12, 2 carry 1, 3 1s are 3, 4, 3 4s are 12, 1, 3 1s are 3, 4, 42.42 meters is the answer. Understood? Okay, this is 16. Let's quickly get to the next question. Question 17. This is the figure for it. Now from the top of a tower, the angles of depression, so I'll just explain it here. This is the tower, right? From the top of the tower, which is at A, the angles of depression of two objects on the same side of the tower, so the objects are kept at D and C, so are found to be alpha and beta, alpha greater than beta. So this will be beta and this will be alpha, right? So this alpha, this angle will also be alpha because it will be alternate angles, and again this angle will be beta again because there will be alternate angles, right? If the distance between the objects is P meters, show that the height h of the tower is given by, so we need to find h. Again there is a common side, right? H is the common side, and obviously we can equate the two values of h that we get from, you know, triangle ABD and triangle ABC. But if we do that, what will happen is you won't get the value of h directly, you will get the value of this BC, which is x, because when you equate the two values of h gets eliminated, so you won't get the value of h, you will get the value of x or p, right? So I'm going to try the other method that we talked about. What was the other method? that was CD equal to this distance is equal to BD minus BC, right? And then we'll see what happens. Okay, so let me write here. So what we are aiming to do is CD equal to BD minus BC. So let's first calculate BD. BD is the side of triangle ABD. So in triangle ABD, now BD is the base and AB is the perpendicular with respect to this angle beta of triangle ABD. So obviously we are going to take tan. So tan beta equal to H divided by BD, right? So BD will be what? BD will be H by tan beta. Let's call it 1. Now in the other right angle triangle, in triangle ABC, BC is the base, AB is again the perpendicular. So again we are going to use tan of the angle. So this perpendicular and base is with respect to this angle alpha. So tan of alpha equal to perpendicular H by base is BC. Fine. So from here BC will be H by tan alpha. Let's call it 2. Fine. Now we need to calculate CD, right? Choose another color. So now CD is equal to BD minus BC. What is CD given to be? CD is given to be P. So P equal to, what is BD? BD is this. So H by tan beta. What is BC? BC is this, H by tan alpha. Or P equal to, take the LCM. LCM would be tan beta into tan alpha. Okay, here will be H tan alpha minus H tan beta, or take this tan beta into tan alpha to the other side. So we get P times, we can write it as tan alpha into tan beta equal to, on the RHS we'll take H common, we'll get tan alpha minus tan beta. We wanted to find the value of H, right? So we're going to write H equal to, so this thing is multiplied to H, so when it goes to the other side it will go into the denominator. P tan alpha into tan beta by tan alpha minus tan beta. So hence proved, right? Now the other part of the question, the second part of the question is height of the tower is what you have to find. The values are given, P equal to 50 meters, alpha equal to 60, beta equal to 30 degrees. So let's quickly calculate here itself. H equal to P is 50 meters, tan alpha is tan 60, that will be root 3, tan beta is 1 by root 3, tan 30 degrees will be 1 by root 3 by tan alpha minus tan beta. So this cancels with this. What you get is 50 by 3 minus 1 into root 3. So the answer will be 25 root 3 meters, or you can just calculate it using this, I mean just in decimals if you want the value. So 5 to the 50, 0, 5, 25, 375, 80, 8, 175, 3, 18, 25 on the 25, and 18 would be 43. So it'll be 43.3 meters, right? So I'm not showing the actual working for this, I mean in detail, because this is a very simple thing, right? You just have to substitute the values and get to the answer. So I've given you the answer, it will be 43.3 meters. Fine. Let's quickly do the next question. Okay. Very quickly, from a window h meters high above the ground. So this is the window which is h meters high. Okay, so h meters above the ground. BC is the ground. So this is the ground. This will be 90. Okay. The angles of elevation and depression of the top and foot of another house on the opposite side of the street are theta and phi. So angles of elevation, angle of elevation is theta, angle of depression of the foot of another house, AB is the other house. Fine. This is the another house, right? This depression is 5. So when you join this point, the observer's position to the foot of the other building, this WP is the horizontal line. You get phi as the angle of depression. This angle will also be equal to this angle because there will be alternate angles. Now this is h, so this will also be h. AP we are assuming to be x. Okay, show that the height of the opposite house is h into 1 plus tan theta into cot phi. Fine. So what is the height of the other house? That is AB. So that is what we need to find. Now when we need to find AB, you know that PB is what? PB is h, right? And h is a given variable. I mean, it's a given thing. So you can give your answer in h, and in fact, you have to prove, right, that the height is h into 1 plus tan theta into cot phi, and that has h. So h is a known thing for you. You don't have to eliminate h, right? So PB is given to be h. If we are able to find AP, then we'll get AB. We'll just add AP to h, right? So we'll get AB, the height of the opposite building, opposite house. So let's focus on finding AP. Now AP is this. We are assuming it to be x. Now in this, do you notice that PW or WP is the common side of two right angle triangles, triangle APW and triangle BPW, right? So now we are going to find this common side using the two triangles with the help of sine, cos and tan, and then we are going to equate the two values, and it will hopefully give us the value of x, and then we'll add it to h to get the height of the opposite building. Okay, so there you go. Now in triangle APW, theta is the angle. With respect to theta, this is the perpendicular and this is the base. WP is the common side we are trying to find the value of. So we are going to use tan theta equal to perpendicular by base is WP, or WP, take WP to the other side and this tan theta to the right hand side. WP will be x by tan theta. Let's call it 1. In the other triangle, in the other right angle triangle, we have in triangle BPW, that is. So this is the angle given, right? Now with respect to this angle phi, this is the perpendicular and this is the base. So again we are going to use tan. So tan phi equal to perpendicular, which is h, divided by base, that is WP. This value is h, right, because this is h, and BP WC is a rectangle, so opposite sides will be equal, right? So if this is h, this will also be h. So now again take WP to the other side, so WP will be equal to h by tan phi. This is 2. Now from 1 and 2, what can we say? From 1 and 2, this is also WP, this is also WP, so both have to be equal. So x by tan theta equal to h by tan phi. Now we need the value of x, so x equal to h times h by tan phi into, take tan theta to the other side, so it will go in the numerator, go like this. Now x equal to h tan theta into 1 by tan phi. 1 by tan phi is what? It is cot phi, because cot is the reciprocal of tan. So this is what we get. Now therefore what will AB be? AB is the height of the other building, height of the opposite house that we need to find. AB is what? AB is AP, that is x, plus PB, which is h. So this is x plus h. X is what? H tan theta cot phi plus PB h, right? Take h common, h into tan theta cot phi plus 1, or this can also be written as h into 1 plus tan theta into cot phi, because a plus b equal to b plus a, right? Hence proved, right? So this is it for today. I would suggest you solve as many questions as possible from whatever books you can get hold of, and you can come up with the questions, doubts, and ask me directly. So thank you. If you like what you saw, don't forget to hit the subscribe button. This is Abbyshek Chandra signing off. Take care.